Right, measurement is a context for algebra. Now remember, this is for an exam with no calculators allowed. So question 1, find an expression for the perimeter and area of, and I can see it's a rectangle, so we could add the other sides. So the perimeter would be x plus x plus x plus 3 plus x plus 3. And gathering that all together, we get 4x plus 6. Now the area of a rectangle is length times width, so it would be x times x plus 3, which would equal x squared plus 3x. Right, now if the perimeter is 34, find x, so we take our formula for the perimeter, that equals 34, and I'm asked to find x. So some simple rearranging. X is going to equal 7 centimetres, and you could always check with a quick 7, and that would be 10, which would give me 20, 34, so we're right. Right, now the area, x squared plus 3x equals 40. It's a quadratic equation, and I know for a quadratic I'm supposed to get 0 on one side. It's the technique we use for solving quadratics. Because now I can factorise. 5 times 8 is 40. So we need a plus 8 and a minus 5. Which means x equals negative 8 or 5. Now obviously x can't be negative 8, so we'll circle that and write unsuitable. Which means x is 5. We could check once again that in fact 5 by 8 of course gives me 40 square centimetres. Right, now we're up to a triangle. We want an expression for the hypotenuse h. Well, it's right angled, so that would mean h would be the square root of, now Pythagoras' theorem, x squared plus x plus 7 all squared. Really important that you put the x plus 7 in brackets. We could leave it like that, but we could also show off some expanding of that with the quadratic. X squared plus, now if we square that, remember we need the middle term, 14x plus 49, and tidying that up we get 2 lots of x squared plus 14x plus 49, and whatever like that. So any of those would be acceptable. Now we want an expression for the area of the triangle. It's easier for triangles if you write the area as base times height divided by 2. And so for this example, we've got the base times the height. We want to divide that by 2, so we could leave it like that. We could expand the numerator. There's the formula for area. And now we're told that if the area is 30, so if that equals, oops, it's supposed to be a 2. If that equals 30, find x. So an equation to solve, multiplying by 2, because for the triangle we had to divide by 2. X squared plus 7x equals 60. Subtracting 60 because we've got a quadratic, so we like to get 0 on the right hand side. And now we could factorise. We need factors of 60. 6 and 10, 5 and 12 would probably work. Plus 12 minus 5, which means x equals negative 12 or 5. Negative 12 is unsuitable. Can't have a negative length, which means x is 5. So we could just check the 5 there. Now this side was x plus 7, so 5 and 7 is 12. And the area of that would be 5 times 12 is 60. Half of 60 is 30 centimetres squared, so that works. Right, question 3. Expression for the shaded area. Well, we know that the area of a circle is pi times r squared, so the area for the whole big circle would be pi capital R squared. And then if we subtract off the area of the smaller one, something like that. And we could take out a common factor of pi, just to show off a little bit more algebra. Now if the radius of the largest circle is 3 centimetres more than the radius of the small one, find and simplify an expression for the shaded area. Right. So the radius of the largest circle is 3 centimetres more than the radius of the small one. So if we go back to the original, so capital R must equal little r plus 3. We need to do some simplifying on that. And if that's a bit quick, you can always expand r plus 3 yourself in the corner. So that's expanding by pi. I can see that those two terms are going to cancel. We get 6 pi r plus 9 pi. And once again, we could show off some factorising if we want to, pulling out the 3 and the pi, leaving me with 2 r plus 3. Now if the area is 63 pi, find both radiuses. Right, so 3 pi equals 63 pi. Now the good thing is that we've got pi in our answer on the right hand side as well, so we could actually divide both sides by pi, and while we're at it we'll divide both sides by 3 times pi, because then we'll get some cancelling. Which would mean that the big radius, which was 3 centimetres more than that, must be 12. Now you can pause and have another wee look at that. Try it by yourself. We've got a trapezium, so perimeter should be straightforward. 4 plus a plus 4 plus a plus 5. Area of a trapezium. We need to add together the two parallel sides, divide by 2, and then we times by the perpendicular height between them. So if you're a bit rusty on trapeziums, the formula is a plus b divided by 2 times the height, where a and b are the two parallel sides. So simplifying that, we'd get 2a plus 5, that's times 3 over 2. We could expand that further if you wanted to. Get 6a plus 15 all over 2.